Hi, 7th grade. Welcome to Lesson 5-4, Solve Inequalities Using Addition or Subtraction. By the end of the lesson, I want you to be able to say, I can solve inequalities using addition or subtraction. Let's explain it. Selena and Martin are waiting at the bus stop. The number of lines show the possible wait times in minutes, T, for Selena and Martin. So Selena's possible wait time says that there's a bus every 15 minutes. So that means if she just missed the bus, she'd have to wait 15 minutes. If not, it could be less than 15 minutes. Martin's app says his blue bus is delayed, which means it's going to take longer than 15 minutes. It couldn't take 15 minutes because then it wouldn't be delayed at all. It'd be on time. So it's going to be more than 15 minutes. Construct arguments. Who anticipates a longer wait? Justify your response with a mathematical explanation. All right, what do we think? Selena or Martin? I agree, Martin. Because he's going to have to wait longer than 15 minutes. And Selena's not going to have to wait any longer than 15 minutes. If Selena and Martin both wait 10 minutes for the bus, whose possible wait time was closer to his or her actual wait time? Explain. So is 10 minutes closer to, it could have been anywhere, for Selena, she could have been 15 would be her longest wait time. So if we did 15 take away 10, the most she would have to wait is 5. Martin, it's going to take more than 15 minutes. So the least amount he would have to wait is 16 minus 10 is 6. So Selena is closer to her wait time. All right, focus on math practices. Be precise. If Selena and Martin both wait exactly 15 minutes for the bus, whose possible wait time was closer to his or her actual wait time? Explain. Selena could have waited, she actually waited 15 minutes, and we knew she was going to wait either 15 minutes or less, and so it could have been the same, and Martin's would have been off by 1 minute, because he thought he was going to have to wait at least 16 minutes for it. All right, on the next page, example 1, solve inequalities. Inequalities is one of your new vocab words. That's that sign where it's less than, greater than, less than or equal to, or greater than or equal to, that involve addition. On the airline that Raul is using, the weight limit for both suitcases combined is 50 pounds. So that's the weight limit. It cannot be over 50 pounds, but it could be less than 50 pounds, or it could be equal to 50 pounds. How much can Raul's second bag weigh without going over the limit? So we know that it is 38 pounds, but we don't know the weight of the second bag. They use P. So solve an inequality, write an inequality to represent the situation. Then solve to find the weight of the second bag, P. So they do the weight of the first bag, it's 38, plus the unknown weight of the second bag. Now we know it's got to be either less than or equal to 50. So think of the less than kind of looks like an L if we were to squeeze it down. And then the equal to is that bottom line, 50. Now, solving an inequality is just like solving an equation. So we're trying to get the variable by itself. So if we look, we are trying to isolate P. So how do we get P by itself? Well, we got to get rid of the 38. 38 is positive, so we're going to subtract it from both sides. 38 minus 38, that cancels, and we bring the P down. So whatever you do to one side, you have to do to the other. 50 minus 38 is 12. So that means that the weight of the second suitcase could be as much as 12 pounds. If it was 13 pounds, it would go over. But if it was 11 pounds, we'd still be in the right space. So we use the inverse relationship between addition and subtraction to isolate the variable. And the subtraction property of inequality is like the subtraction property of equality. Subtracting the same number from both sides maintains the inequality. So now we have to use a number line. So we know that it could weigh 12. That's why we're going to put a point at 12. Now we're going to talk about, could it be less than, could it be more than? Could it be 13? No, because then we would go over our 50 pounds. So we're going to draw our line with the arrow going backwards. Raul's second bag must weigh 12 pounds or less to avoid going over the weight limit for both suitcases combined. Let's try it. Kayoko has completed 26 hours of community service. Her goal is to complete at least 90 hours this semester. So at least 90 hours. Could she make more than 90? Yeah. Could she make less than 90 and still reach her goal? No. Write and solve an inequality to show how many more hours H Kyoto needs to complete to meet her goal. Use the number line to graph the solutions. So she already has 26. So we have 8 plus 26. And we know that the amount of hours she makes, we want it to be greater than or equal to 90. So you're going to draw your sign facing the hours. Now we're trying to get H by itself, so we need to get rid of that 26. So we are going to write the 26 in. Let's subtract the 26 because it was positive. Whatever you do to one side, you do to the other. We'll bring down our inequality symbol. These 26s will cancel out. Bring down the H, bring down the inequality. 90 minus 26, 64. So the amount of hours that she does community service for, she could either do 64 hours and exactly meet her goal of 90, or she could do more and exceed her goal. So we're going to put a point at 64, and we say she could do more hours. So we're going to draw our arrow facing the right. Is there more than one solution to the problem about Kyoto? Explain. Give one value that is a solution and one value that is not solution. So yes, there is more than one solution because it could be any number 64 or larger. So one solution could be 90. One not a solution would be 60. All right, example number 2. Solve inequalities that involve subtraction. The weather forecast predicted that the evening temperature could get as low as negative 12.5 degrees Fahrenheit. Between afternoon and evening, the temperature dropped by 7.5 degrees Fahrenheit, which was consistent with the forecast. What could the afternoon temperature T have been? So we don't know what the temperature was, but we know it could be as low as negative 12.5. Could it get lower than 12.5? No. Could it be higher than 12.5? Yes. So we take our original temperature T, but we know it dropped by 7.5, so that's why we're going to subtract 7.5. And we know that temperature has to either be greater than or equal to negative 12.5. Now I'm trying to solve for T, so using those rules of inequality, I'm going to add 7.5 to both sides because that will cancel out on the left. Whatever you do to one side, you have to do to the other. Bring down the T, and negative 12.5 plus 7.5 is negative 5. So that means that the temperature could be negative 5, or it could be greater than negative 5, so bigger. So we're going to draw our line, arrow to the right. Let's try it. The speed limit on a road drops down to 15 miles per hour around a curve. So this is important. Drops down to 15 miles per hour. Mr. Gerard slows down by 10 miles per hour as he drives around the curve. He never drives above the speed limit. At what speed was Mr. Gerard driving before the curve? Graph the solution. So we don't know the speed he was driving, so we can use S. But when we went down around the curve, he slowed down 10 miles per hour. He doesn't drive above the speed limit. We know the speed limit was 15. Could he drive less than the speed limit? Yeah, so his could be less than, or he could drive exactly the speed limit or equal to. So now we're trying to find his speed, S. So to get rid of that negative 10, we're going to add 10 to both sides. So that cancels out on the left. We have S, bring down your less than or equal to, and 15 plus 10 is 25. So he was driving either 25 miles an hour or less. So we're going to draw a number line. I'm going to put 25, put 20, put 30. Just has to be a rough sketch. Okay, so we're going to put a point at 25 because that's the most he could have been going, or he could have been driving less than that. So draw my arrow to the left. Solve more inequalities. Solve the inequality x minus 1/2 is less than negative 2/3. Okay, this is only tricky because it has fractions, but you guys can do this. So we are going to get the variable by itself, x. Right now, negative 1/2 is being subtracted. Well, 1/2 is being subtracted, so we're going to add it to both sides. Cancels out on the left. And now they skip this step, which I don't know why they do that. But negative 2/3 plus 1/2. Can I add these yet? No, I need them to have a common denominator. So between 3 and 2, my common denominator is 6. So I'm going to multiply the first fraction by 2 over 2 and the second fraction by 3 over 3. So negative 2 times 2 is negative 4/6, and 1 times 3 is 3. Negative 4 plus 3 is negative 1, and we keep our denominator of 6. So that's where they got that from. X is less than negative 1/6. Now, could it be equal to negative 1/6? No. So this is why we see something new here. Please pay attention. If it cannot be equal, we don't fill the circle in at that spot. So they just put a circle at negative 1/6 and then not fill it in and then draw our arrow to the left because x could be anything smaller than that. All right, solve the inequality n minus 1 3/4 is less than or equal to negative 5/8. Okay, the first thing I'm going to do here, just because I see this happening, is I need a common denominator and I need to make these improper fractions. So let's make it an improper fraction first. So we got to get mad, and we'll multiply and add. So 1 times 4 is 4, plus 3 is 7. So we've got n minus 7/4 is less than or equal to negative 5/8. Now I want a common denominator between 4 and 8. That common denominator is going to be 8. So all I have to do is multiply the first fraction by 2 over 2. So now I have n minus 14 over 8 is less than or equal to negative 5/8. All right, I am trying to get the n by itself. So to get rid of the negative 14/8, I'm going to do the opposite, and I'm going to add 14/8 to both sides. It cancels out on the left. Bring down the n, bring down the inequality. Negative 5/8 plus 14/8 is 9/8. And we can make that 1 and 1/8. Do they ask us to graph it? Yep. Okay, so I'm going to draw my number line. I know I'm going to have a point at 1 and 1/8. So then bigger than 1 and 1/8 is 2, less than 1 and 1/8 is 0. Just a sketch. I could be equal to positive 1 and 1/8, or I could be less than, smaller than that. All right, 7th grade, let's say it. Okay, I can solve inequalities using addition or subtraction. Have a great day.